Good day everybody, we got an interesting question. Integral of a sum from 1 to infinity 6 raised to the power of n divided by 3 raised to the power of n positive 1 negative 2 raised to the power of n positive 1 times 3 raised to the power of n negative 2. This is multiplied with, this sum is multiplied with 1 over x squared positive 1 raised to the power of 3 times dx. So clearly you can see that the quantity n is completely independent of the variable x here. So I can cordon this off and I can evaluate this. So what I'm going to do is I'm going to consider sigma 6 raised to the power of n divided by 3 raised to the power of n positive 1 negative 2 raised to the power of n positive 1 multiplied with 3 raised to the power of n negative 2 raised to the power of n. Of course the summation starts from 1 and goes up to infinity. Now what I wish to do is I would like to consider the denominator. The denominator is 3 raised to the power of n positive 1 negative 2 raised to the power of n positive 1, and that is product multiplied with 3 raised to the power of n negative 2 raised to the power of n. So let me distribute this. This into this is going to be equal to 3 raised to the power of n positive 1 multiplied with 3 raised to the power of n, and then this into this, that's going to be negative 3 raised to the power of n positive 1 multiplied with 2 raised to the power of n. Then this into this, that's going to be negative 2 raised to the power of n positive 1 times 3 raised to the power of n. Then this into this, negative will be positive, so 2 raised to the power of n positive 1 times 2 raised to the power of n. Now 3 raised to the power of n positive 1 times 3 raised to the power of n. This is similar to a raised to the power of m times a raised to the power of n, which can be rewritten as a raised to the power of m positive n. So that would mean this is going to be 3 raised to the power of n positive 1 positive n, which is nothing but 3 raised to the power of 2n positive 1. So having got that, let me also rewrite this. So this is equal to 3 raised to the power of 2n positive 1. I have to evaluate this quantity. So let me consider this 3 raised to the power of n positive 1 with the negative sign times 2 raised to the power of n negative 2 raised to the power of n positive 1 times 3 raised to the power of n. This is rewritten as negative 3 raised to the power of n times 3, right, by the rule of it is as a raised to the power of m positive n can be rewritten as a raised to the power of m times a raised to the power of n, followed by 2 raised to the power of n times 2 times 3 raised to the power of n. Of course there is a 2 raised to the power of n there, so let me write that over here. Now if you were to take 3 raised to the power of n and 2 raised to the power of n common out, this is going to be negative 3 followed by a negative 2, which is going to be 3 times 2 is 6 raised to the power of n multiplied with negative 5. So this is what you have got. So I'm going to take this value and place this over here, negative 5 times 6 raised to the power of n. Now this is going to give me positive 2 raised to the power of 2n positive 1. Okay, so the numerator was considered and the quantities in the, I would say the denominator was considered, the quantities in the denominator were distributed, and then this is what you have got. So now let me write this down. So this is equal to sigma 1 to infinity 6 raised to the power of n divided by 3 raised to the power of 2n positive 1 negative 5 times 6 raised to the power of n positive 2 raised to the power of 2n positive 1. Now I'm going to rewrite this as sigma 6 raised to the power of n divided by 3 raised to the power of 2n multiplied with 3 negative 5 times 6 raised to the power of n positive 2 raised to the power of 2n multiplied with 2. Now what I wish to do is I would like to divide the numerator and the denominator by 6 raised to the power of n. So that would give me sigma 6 raised to the power of n divided by 6 raised to the power of n divided by 3 raised to the power of 2n times 3 divided by 6 raised to the power of 2n negative 5 times 6 raised to the power of it's actually 6 raised to the power of n, not 2n, divided by 6 raised to the power of n positive 2 raised to the power of 2n times 2 divided by 6 raised to the power of n. Now this and this can be cancelled, giving me sigma 1 divided by, now I wanted to actually do something about this. Okay, so what I'm going to do is I'm going to write this as 3 raised to the power of n, right, and that is okay. I will write this as in this following fashion: a raised to the power of m times n can be rewritten as a raised to the power of n times m, which is equal to a raised to the power of n raised to the power of n. So you can do those manipulation with the indices. So what I wish to do is 3 raised to the power of 2n. I'm going to write it as 3 raised to the power of 2, the whole raised to the power of n. Fair enough, right? Multiplied by 3 divided by 6 raised to the power of n. Now these two gets cancelled, giving you negative 5, positive. Now this is going to be 2 raised to the power of 2, the whole raised to the power of n, divided by 6 raised to the power of n times 2. Okay, so this is equal to sigma 1 divided by, this is 9 raised to the power of n divided by 6 raised to the power of n, with multiplied with 3, negative 5, positive 4 raised to the power of n divided by 6 raised to the power of n times 2. So this can be further rewritten as sigma 1 over, I want to write this as 9 over 6 the whole raised to the power of n. Fair enough, right? Because the exponents are one and the same. That is multiplied with 3, negative 5, positive 4 over 6 the whole raised to the power of n multiplied with 2. Okay, so this is what we have got. We'll have to move on to the next page. Okay, so let me move on to the next page. I want to change my pen. Okay, so this is what I have got. Let me take a fresh page. Okay, so this is equal to sigma 1 over 9 over 6 the whole raised to the power of n times 3, negative 5, positive 4 over 6. I'm going to rewrite it as 2 over 3 raised to the power of n multiplied with 2. Okay, this is what I've got. Now 3 divides here 3 times, 3 divides here 2 times. So this is equal to sigma 1 over 3 over 2 raised to the power of n multiplied with 3, negative 5, positive 2 over 3 raised to the power of n multiplied with 2. This is what we have got. Now the question is, we will have to reduce this. Now I would like to let 3 over 2 raised to the power of n to be equal to sum p. Now what can you say about 2 over 3? Now 2 over 3 raised to the power of n can be rewritten as 1 over 3 over 2 raised to the power of n, which is equal to 1 over 3 over 2 raised to the power of n, right? Which is equal to, what's here? 3 over 2 raised to the power of n is p. Now 3 over 2 raised to the power of n is over here. So this is nothing but 1 over p. So therefore we have, what do we have? We got 2 over 3 raised to the power of n to be equal to 1 over p. Now if I were to take this as sum alpha, right, so therefore alpha will be rewritten as sigma 1 over 3 times p negative 5 positive 2 times 1 over p, right? Now I want to take p as the LCM. So this is sigma. If I were to take p as the LCM, I would get 3 times p squared negative 5 times p positive 2 divided by p. You flip the p, you get sigma 1 over sigma p over, in fact, okay, let me continue. I don't have to place the sigma here. I would just get rid of the sigma. I don't want to place the sigma as of now. So what I will just do over here is consider, I will first evaluate this term. Consider 1 over 3 times 3 over 2 raised to the power of n negative 5 positive 2 over 3 raised to the power of n times 2. So I'm just going to consider, and that would mean I don't want to place the sigma. The reason, because I'm introducing a new variable p. So this is rewritten as this is rewritten as, okay, so I also don't want to mention your alpha. Okay, I'll just say hence this becomes, hence I will write this step, hence 1 over 3 times 3 over 2 raised to the power of n negative 5 positive 2 over 3 raised to the power of n times 2 becomes, okay, so that this becomes this, and this becomes this. And what is this? This is going to be 3 times p squared negative 5p positive 2. Now what I wish to do here is I want to factorize this. So using quadratic, this is going to be equal to p is equal to 5 plus or minus root of 25 negative 4 times 3 times 2 divided by 2 times 3, which is equal to 5 plus or minus root of 25, 12, 24 divided by 6, which is equal to 5 plus or, okay, I take plus 1 first, 25 negative 24 is 1, root of 1 is 1, divided by 6, you get 6 over 6 is equal to 1. This is 5 negative 1 over 6, which is 4 divided by 6, 2 divides here, 2 times 2 divides here 3 times, so you have 2 over 3. So therefore 3 times p squared negative 5p plus 2 is rewritten as 3p negative 2 multiplied with p negative 1. Okay, so this is what we have got, but now we can rewrite this over here. This is equal to p over 3 times p negative 2 multiplied with p negative 1. Okay, now what I wish to do is I would have to utilize partial fractions. Let's do that. Okay, so I want to use this page here. So this quantity which you see here is going to be rewritten as follows, so using partial fractions. So I'm going to write p divided by 3p negative 2 multiplied with p negative 1 is equal to a over 3p negative 2 positive b over p negative 1. Cross multiply, you get p is equal to a times p negative 1 positive b times 3p negative 2. So I want to make one of the terms is equal to 0. So let p is equal to 1. This vanishes. This is going to give you 3 minus 2. That means b is equal to 1 or 1 is equal to b. Now next I want to take, let p be equal to 0. So that would mean you have 0 is equal to negative a, p is equal to 0. This is going to be negative 2 times b. A has to be found, b is 1. So negative a is equal to 2. Therefore the value of a is equal to negative 2. So this is what we have got. So now what I wish to do is I will have to place in these values, negative 2 and 1. So now what you can do is you can take these values and substitute it instead of this. So therefore p divided by 3p negative 2 times p negative 1 is now equal to a is negative 2 divided by 3p negative 2 positive b is 1 over p negative 1. So this is what you have got. So now if you would remember, I have taken the value of p to be equal to 3 over 2 raised to the power of n. Okay, so substitute that. So this is equal to negative 2 over p is 3 over 2 raised to the power of n. Okay, negative 2 plus 1 over 3 over 2 raised to the power of n minus 1. Now this has actually resulted because we exclusively considered this term. So now since I have reverted back to n, therefore I can rewrite, therefore sigma 1 over 3 of 3 over 2 raised to the power of n negative 5 positive 2 over 3 raised to the power of n times 2, which is actually this, right? 1 to infinity, and from here we consider this exclusively. So this quantity exclusively is now this. Okay, so take this and substitute here. So this becomes is equal to sigma negative 2 divided by 3 times 3 over 2 raised to the power of n negative 2 1 to infinity positive sigma 1 over 3 over 2 raised to the power of n negative 1. I need to have a new page, so let me go over here, okay, and do it. So this is what I've got. Okay, so what I wish to do is I would like to consider this. Consider sigma negative 2 over 3 times 3 over 2 raised to the power of n minus 2. Now let me take 2 out. This is 1 to infinity. So if I were to take 2 out from the denominator, this is going to be rewritten as 3 over 2 times 3 over 2 raised to the power of n minus 1. Okay, in the numerator you got minus 2 and this is sigma. So 2 and 2 gets cancelled. You get sigma negative 1 over 3 over 2 raised to the power of n times 3 over 2 negative 1. So this is the next quantity. This is the quantity. Now what's this? Now what is this? So therefore if I were to take this as say some beta, I can rewrite, therefore beta becomes what? Beta is now rewritten as sigma negative 1 over 3 over 2 raised to the power of n times 3 over 2 negative 1 positive sigma 1 over 3 over 2 raised to the power of n negative 1. So this is the term I am talking about, this term and this term. Okay, so 1 to infinity. 1 to infinity. So now what we need to do is we need to substitute when n is equal to 1. So when n is equal to 1, find the sum. What happens when n is equal to 1? You get negative 1. N is equal to 1. You get 3 over 2 and 3 over 2 minus 1. N is equal to 1. You get 3 over 2 minus 1. Now this is equal to negative 1 over, this is 3 over 2 times 3 over 2, that's 9 over 4. 9 over 4 minus 1 plus 1 over 3 over 2 minus 1. So this is equal to negative 1 over 5 over 4 plus 1 over 2, which is negative 4 over 5 plus 2 over 1. Now when n is equal to 1, you have got negative 4 over 5 plus 2 over 1. Right? This is what you've got. Now let me move on to find what is the value when n is equal to 2. When n is equal to 2, this is going to give me negative 1 over 3 over 2 raised to the power of 2 times 3 over 2 negative 1 plus n is equal to 2. That's 1 over 3 over 2 raised to the power of 2 negative 1. So this is going to be equal to negative 1 over 3 3s are 9. 9 into 3, 27. 4 2s are 8. Negative 1 plus 9 over 4 negative 1, which is equal to negative 1 over, this is going to give me 19 over 8, and this is going to give me 5 over 4. So if you were to flip this, you get 8 over 19 and 4 over 5. Okay, for n is equal to 2. Now let me move on for n is equal to 3. N is equal to 3, you get negative 1 over 3 over 2 raised to the power of 3, 3 over 2 negative 1, positive 1 over 3 over 2 raised to the power of 3 negative 1, and this is going to be negative 27 times 3, 81, 8 16 negative 1 positive 1 over 27 over 8 negative 1, which is equal to negative 1. This is going to be, from 81 you take away 16, so this is going to be 5. 7 you take away 165, so this is 65 over 16 positive 8 19 over 8. So you flip this. This is 16 over 65 negative 2 positive 8 over 19, right? So this is what you've got. Now let me do one more term so that you can get that understanding. Now when n is equal to 4, this is negative 1 3 over 2 raised to the power of 4, 3 over 2 negative 1 positive 1 over 3 over 2 raised to the power of 4 negative 1. Now this is 81 already, times 3 243. So this is going to be negative 1 over 243 divided by 1632 negative 1. So from 243 you take away 32. This is 213 plus this is 2781 over 16 negative 1. So which is equal to negative 1 over, this is going to be 211 divided by 32 positive 1 over 81 negative 16. So from 81 you take away 16, you get a 5 7 65. So this is going to be 65 over 16. So you flip it, you get 32 over 211 plus 16 over 65. Are you following the pattern? Now clearly you see here. Now this is the first term you are getting. Now the first term gets cancelled with the second term of the value when n is equal to 2. So what happens here? I can easily cancel the first term with the second term. So the first term that we get here gets cancelled with the second term. The first term that we get here gets cancelled with the second term. You follow me? So as you proceed on to n is equal to infinity, all the terms will get vanished except for this term that we get 2. So therefore what is the sum? Therefore the sum 1 to infinity, n is equal to 1 to infinity of 6 raised to the power of n divided by 3 raised to the power of n positive 1 negative 2 raised to the power of n positive 1 multiplied with 3 raised to the power of n negative 2 raised to the power of n is equal to 2. This is the value. So we have got one part, but there is another part. Let me show you the other part. Okay, this we need to do this part. So I have successfully evaluated the value of the sum, which is 2. Now I need to integrate this. So therefore if I were to take this as say some gamma, so gamma becomes equal to integral, the sum that we have just calculated is 2 times 1 over a squared positive 1 raised to the power of 3 times dx, which is equal to 2 times integral dx over x squared positive 1 raised to the power of 3. So how are we going to integrate this? Now what I'm going to do is I would like to take, let me take x is equal to tan theta. Let x be equal to tan theta, dx is equal to secant square theta. So this is 2 times dx is secant square theta, this is tan square theta plus 1 raised to the power of 3, but secant square theta negative tan square theta is equal to 1. So secant square theta is 1 positive tan square theta. So this is equal to 2 times integral secant square theta d theta divided by secant square theta raised to the power of 3. This is equal to 2 times integral secant square theta d theta 2 raised to the power of 3. That's going to be secant raised to the power of 6 theta, which is equal to 2 times integral. I can cancel a secant square theta with the secant square theta, so that would give me 1 divided by secant to the power of 4 theta d theta. Now since secant theta is equal to 1 over cos theta, this is equal to 2 times integral cos to the power of 4 theta d theta. I can rewrite this as 2 times integral cos square theta times cos square theta times d theta. I need to get a new page. So this is equal to, I'm wondering if I have it. Okay, I think I can use the space here. So this is equal to 2 times integral. Now cos square theta is 1 positive cos 2 theta divided by 2. So this is 1 positive cos 2 theta, right, divided by 2, and this is multiplied with 1 positive cos 2 theta divided by 2 into d theta. Now this is equal to 2 times integral, this is 2 squared, so I place 2 squared here, and this is going to be 1 positive cos 2 theta raised to the power of 2 times d theta. A 2 and a 2 can get cancelled, giving me 1 over 2 integral 1 positive cos 2 theta. You expand this, you get 1 positive 2 times cos 2 theta plus cos squared 2 theta times d theta. So this is equal to 1 over 2 times integral. Now this can be integrated, this can also be integrated. So foremost what I wish to do is I will just place here 1 positive 2 times cos 2 theta plus cos squared. Now I know that cos squared theta is equal to 1 positive cos 2 theta divided by 2. So if I take theta is equal to 2 theta, so cos squared 2 theta is equal to 1 positive cos 4 theta divided by 2, right? So this is going to be 1 positive cos 4 theta divided by 2. This is what I've got, times d theta. So now what I wish to do is I will have to split this. So this is equal to 1 over 2 integral d theta positive 2 times integral cos 2 theta d theta positive 1 over 2 times d theta. I can split this, right, positive 1 over 2 times integral cos 4 theta d theta, right? So this is equal to 1 over 2 times integral d theta is theta plus cos 2 theta, integration of cos 2 theta sin 2 theta. The coefficient of theta is 2, so we divide by that value, plus integral of d theta is theta, you have a 2 there. Now you got 1 over 2 integral of cos 4 theta, that is going to be sin 4 theta. The coefficient of theta is 4, so this is what you have got. Now 2 and 2 can be cancelled, and this can be rewritten as 1 over 2 times integral theta plus sin 2 theta plus theta over 2 plus sin 4 theta divided by 8. Now these two can be clubbed together, so 2 theta plus theta, that's 3 theta over 2, and plus sin 2 theta plus sin 4 theta divided by 8. Now we need to get the original variable back, so that is what we have to do now. So for that I need a new page. So this is equal to 1 over 2 times, I will write this as 3 theta over 2 plus sin 2 theta is 2 times sin theta cos theta plus sin 4 theta. Now let me go back here. Sin 2 theta is 2 times sin theta cos theta, right? So just a minute. Okay, now I need to get 4 theta, so that means theta is equal to 2 theta. So if I take theta is equal to 2 theta, this is going to be sine 4 theta. This is equal to sine 2 theta into cos 2 theta. Okay, so this is going to be 1 over 8 times 2 times sine 2 theta times cos 2 theta. Now this is also not enough. It's not sufficient. We have to still further go to the extreme of converting all of this in sine and cos. So this is equal to 1 over 2 times 3 theta over 2 plus, this is okay, I'm retaining it as it is, sine theta cos theta, plus 1 over 8 times sine 2 theta is going to be 2 times sine theta cos theta. Cos 2 theta is going to be cos square theta negative sine square theta. Okay, so I'm rewriting this. This is equal to 1 over 2 times 3 theta over 2 plus 2 times sine theta cos theta. I am taking 2 out, so it's going to be 1 over 4, right? So you have 2 times sine theta cos theta into this is going to be sine theta cos cube theta negative 2 times, in fact I could have taken this 2 also, 2 squared, so this is going to be 4 will divide here 2 times, so no need to write this 2 and no need to write this 2. So this is going to be just sine cube theta times cos theta. So this is what we are getting. Okay, so now we need to actually write these quantities in the original variable, which is x. Now we know that x is equal to tan theta, right? So tan theta is opposite side divided by adjacent. So you take the triangle, this is theta, this is opposite side, adjacent side, hypotenuse. This is x divided by 1, so my hypotenuse side is going to be root of 1 positive x squared. So root of 1 positive x squared. So sine theta is opposite side by hypotenuse, that is x divided by root of 1 plus x squared, and my cos theta is adjacent by hypotenuse, so 1 over root of 1 positive x squared. So what you need to do is you need to take these values and substitute it here. So if I were to do that, this is going to be equal to 1 over 2 times, I do not have a theta, in other words I have to evaluate the value for theta, because theta also has to be found, right? So from here theta is tan inverse of x, right, from here. So you can substitute that. So this is going to be 3 over 2 times tan inverse of x, positive 2 times sine is x over root of 1 positive x squared, cos is 1 over root of 1 positive x squared, positive 1 over 2 times my sine is x over root of 1 positive x squared, cos cubed, that's going to be 1 over root of 1 positive x squared raised to the power of 3. Okay, now this is the first term, followed by sine cube x over root of 1 positive x squared raised to the power of 3 times 1 over root of 1 positive x squared. Okay, this okay, alright, so we need to evaluate this. So this is equal to 1 over 2 times 3 over 2 tan inverse of x positive root of 1 positive x squared times root of 1 positive x squared. That's going to be 1 positive x squared. Fair enough. Positive 1 over 2 is going to be product multiplied everywhere. Now I can take 1 root of 1 positive x squared. That would give me 1 positive x squared, and for the rest I've got a degree 3 here, right? So I've got 2 more quantities. So that actually, this is of this fashion, right? root of 1 positive x squared, root of 1 positive x squared, root of 1 positive x squared. 1 I am taking with this, so that becomes 1 positive x squared. The rest 2 can be multiplied, so this is going to be whole squared here. That looks good. X and negative x cubed. Similarly, these two can be multiplied, giving me 1 positive x squared raised to the power of 2. And this is all parenthesis. So this is what we have got. And of course, all of these things can be simplified. You can simplify these two together and you can rewrite it. Let me get another sheet of paper and show you that. Okay, so I can simplify this. So this is 1 positive x squared whole squared. This is going to be x minus x cubed, so it's going to be x times of 1 minus x squared. So this is going to be, and 2 can be just placed here, right, followed by 2 times x divided by 1 positive x squared, followed by 3 over 2 tan inverse of x. Now you got this 1 over 2. You can just bring this 1 over 2. This will become 2 squared. This 2 will be placed here, 2 squared will be placed here. So this 2 and this 2 can be cancelled, giving you 3 over 4 tan inverse of x positive x over 1 positive x squared positive x times 1 negative x squared divided by 4 times of 1 positive x squared whole squared. Now this is an indefinite integral, so you place arbitrary constants. So this is a lovely question, and I hope you all like this. Please like, share and subscribe to our channel. Until we meet again, thank you.